we're gonna learn about Newton's laws of motion. I'm sure you all heard of Isaac Newton. He got the idea of gravity when an apple fell off a tree and hit him on the head. While working, he came up with three basic ideas that are applied to the physics of most motion. His ideas are known as Newton's law of motion. Now let's learn about Newton's first law of motion. The first law stated that an object at rest stays at rest and an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. In simple words, it means that the object continue to do what they are doing. For example, like the first ball, if it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Only unbalanced force can change this. If it's at rest, an unbalanced force acts on it, it will move. If it's in constant motion, an unbalanced force acts on it, it will accelerate or change direction. And this is the first law of motion, also known as law of inertia. Okay, so let me give you another example. See, this ball on the table is not moving. It means it's an object that is at rest. When you push it with your finger, it starts rolling. See, it's not stopping. Oh, the book came in its way. It will stop now. So this clearly means that moving objects do not change their route or direction unless something forced them to stop. Okay, some force causes them to stop. Let's take one more example. Imagine you're in space and you kick a ball. It will keep moving forever and ever and ever because there is no force or blockage to stop this. You may ask me why when you're kicking a ball it actually stops and not continue moving. Well, this law says that the moving objects will continue moving when there is no other forces acting on it. On Earth, when you are kicking a ball, there is the force of gravity pulling the ball down to the ground and the force of air resistance slows it down, as well as the force of friction between the ball and the ground that make her stop. This may sound strange, but it's true. Come on now, let's try to move this large couch. It's not moving. It is stubborn? No, because the force you applied is not enough to move this big couch. But you can move the chair easily because the effort you're putting is enough to move this. This is because of inertia. Inertia tells us how strong an object's tendency is to resist change in its state of motion. Think of it like this. There is a tiny brick kept on a table next to a relatively larger and a heavier brick. Which do you think would be easier to push? Without any doubt, the tiny brick. But why is that? It's because the heavier the object is, the more is its tendency to resist change in motion. And the more mass an object has, greater will be its inertia. Just to refresh your memory, inertia is the tendency of an object to resist change to its state of motion. And mass, we can say that the mass is the measure of its inertia. So the first law focuses on when there is no unbalanced force, in other words, when the force is balanced. For the second law, actually we are focusing on the moving objects that are accelerating and the force is unbalanced. To understand this law, actually we need to review chapter 10, acceleration. So acceleration depends on two factors. So let me ask you a question and I'm sure you can answer. Let's say there is an object on a table. You apply a net force of 10 units on it. And then you apply a net force of 20 units on it. In which case do you think the acceleration will be more? Of course, the one in which the force was more, right? So we can say that one of the things that acceleration depends on is net force. If it's more, then more will be the acceleration. If it's less, the lesser will be the acceleration. Acceleration depends directly on the net force. Now I want you to think about the second factor the acceleration will depend on. Let's say there are two objects on the table. One has a mass of 3 kilograms and the other has a mass of 5 kilograms. Now if you apply net force of 10 units to each of them, Which one do you think will accelerate more? Surely the 3 kilogram one, because it has lesser mass. Lesser the mass, more the acceleration, and more the mass, lesser the acceleration. We can say that acceleration depends inversely on the object's mass. If you understand this concept well, then understanding the second law of motion will be very easy. Newton's second law of motion stated that the acceleration of an object depends on the mass of the object and the amount of force applied. Now, look at this picture on page 247. If the force applied to the card is the same, the acceleration on the empty card is greater than the acceleration on the loaded card. In this one, the acceleration will increase when a larger force is exerted. This relationship of acceleration to mass and force can be expressed mathematically with this equation. A equal to F divided by M, or F equal to M times A. A stands for acceleration, F stands for force, M stands for mass. We already know the units of mass and acceleration. For force, the unit is Newton. 1 Newton equal to 1 kilogram times meter per second power 2. Now we're gonna apply Newton's second law to solve this problem. What is the acceleration of a 3 kilogram mass if a force of 14.4 Newton is used to move the mass? First, write the values. First step, write the equation for the acceleration, which is force divided by mass. Replace the values. Acceleration is 14.4 kilogram times meter per second power 2 divided by 3 kilogram. You can remove the kilograms, and the result is 4.8 meter per second power 2. Now it's your turn. Solve the problem on page 248 and comment your answer. To understand the third law, you need to ask yourself one question. What happens when two objects interact with each other? What happens when you place a ball on a table? The ball exerts a force on the table, and the table exerts an upward force on the ball. There are two forces that result from this interaction: a force on the table and a force on the ball. The magnitude of the two forces are the same, but the directions are opposite. The forces are called as action force and reaction force. The force exerted by the ball on the table is action force, and the force exerted by the table on the ball is the reaction force. This is a display of Newton's third law of motion. Every action has an equal and opposite reaction. That's how simple the third law is. It means that when two objects interact, there is a force on each one of them. The magnitude of the force on the first object equal to the magnitude of the force on the second one. What about the direction? The direction of the force on the first object is opposite to the direction of the force on the second one. Let's talk about more examples. While a frog is swimming, it pushes the water back, and the water pushes its body forward. Now, will the Newton third law apply when a bird is flying? Sometimes the third law is not so obvious. You would probably say the bird is the only object here, and there is no second object. But that's not correct. The wing of the bird pushes the air downward, and the air pushes the bird upward. Action and reaction forces make it possible for bird to fly. Here you another example. When you're on a boat and step out of it onto the land, you push the boat behind and the boat pushing you forward. And that's why you see the boat go behind when you go forward. Basically, this was Newton's third law of motion. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. This is what we learned today. Newton's first law of motion stated that the motion of an object will not change if no unbalanced force acts on it. Objects at rest will not move unless acted upon by an unbalanced force. Objects object is in motion will continue to move at a constant speed and in a straight line unless acted upon by an unbalanced force. Inertia is the tendency of matter to resist a change in motion. Mass is a measure of inertia. Newton's second law of motion stated that the acceleration of an object depends on the force exerted on it. Newton's second law is represented by the following equation: F equal to m times a. Newton's third law of motion stated that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. And that's it for today. Please don't forget to do your homework and comment it on this post. Good luck! Bye bye!